here we are looking at problem number 6, another acceleration graph question. It says, please answer the questions about the graph below, so we're going to go ahead and do that. First, we want to describe the motion of the object. Is it speeding up, slowing down, moving forwards, moving backwards? It is, in fact, speeding up, and you know that because the slope is getting steeper. It starts off with a flat slope, which means it's at rest, and as you continue in time, this object slope, the slope of its position graph, gets steeper and steeper, which is a clear indication that it's speeding up. Now you also notice that it's a negative slope on this curve, and that indicates that it's moving backwards. So if you were to actually just circle those two answers, I would be okay with that. Now, at time equals 0, the velocity is 0, and that is because the graph is flat. Okay. Now, the average velocity from 0 to 7 seconds versus from 7 to 10 seconds. Let's go ahead and actually calculate that. I'm going to zoom out just a little bit. Perfect. There we go. So I'm going to actually label my points very carefully, just so that we have them clear. So my first point is 0, 4. That's at time equals 0. My position is 4 centimeters. And then at 7 seconds, my object is at a position of 2 centimeters. And then finally, at 10 seconds, it seems that my object crosses the origin. So let's get the average velocity from 0 to 7 seconds. I'll just call that v1, and I'll calculate it here. That's going to be the rise over the run. That's going to be 2 minus 4 over 7 minus 0. I'm just calculating the slope, or kind of an average slope. So that's going to be negative 2 over 7. When you actually put that into your calculator, so it'd be nice to have that as a decimal. That's going to be about negative 0.28. Negative 0.3, whatever, negative 0.28 centimeters per second. And then V2 going from 7 to 10 seconds. Again, we're going to take 0 minus 2, that's the rise, over the run, which is 10 minus 7. And that's going to give us negative 2 over 3. So that's giving us a speed of negative 0.67 centimeters per second. Almost, but not quite 3 times as fast in the backwards direction. So the way that the answer to C shows that it's speeding up, which by the way gives a little bit of part A. I kind of buried that clue in there, didn't I? How does the answer to C show that it's speeding up? It shows this because I would actually be I could say the absolute value of V2 is bigger than the absolute value of V1. I could say V2 has a bigger value than T1. And then V1, that bigger value meaning absolute value. That's another way of saying that. All right. Now the velocity versus time graph. Since we know it's moving backwards, that means that the graph has to live here in the negative part. So we start off at a speed of 0, and moving away from this t-axis means that we're speeding up. So we just proceed in a linear fashion like that. Maybe I could make it a little bit better here. There, that's cooler. There, just like that. So that is question number 6, and we'll do question number 7, and maybe a couple more in the next video.